Ladies and gentlemen, a very good afternoon to everyone, and welcome to our 8th masterclass of the year, brought to you by BEX Asia, the anchor trade exhibition of the International Built Environment Week, IBEW. My name is Suhaimi, and I'll be your host for this web masterclass here today. The 18th edition of BEX Asia will take place from the 3rd to 5th of September at Sands Expo and Convention Center, and you can expect 3 days worth of sourcing from the best technology solutions for the built environment, extensive networking opportunities, and staying in the loop with developments through our educational sessions on site. Now, before I kick off today's masterclass, allow me to go through some announcements. You would have seen this before, the information on screen about International Built Environment Week, but allow me to walk you through it. This year's IBEW returns with the Expert Series, where our conference does deep dives into project case studies, best practices, and real-world examples to help you develop your own expertise. Our content will cover several key domains, including in Day 1, digital construction, where we discuss best practices in BIM, integrated project delivery, and how it impacts the design and construction process. Construction efficiency, where we delve deep into prefabrication best practices, lean construction, and explore new technologies that will bump up the way you work and your capabilities and productivity. In Day 2, we will deep dive into sustainability with content centered on carbon accounting and reporting throughout a building's life cycle from construction to delivery and operations and management. Operations and maintenance, mandatory energy improvement regime that kicks off in October 2025, along with retrofitting case studies around improving energy use intensity, as well as the upcoming refresh green mark standards in Singapore. Tickets to the Expert Series are available now, and the QR code is on screen now for you. Early bird rates will end in August, so do ensure that you get your tickets early so that you can enjoy the best savings available. Also happening as part of IBEW is the BCA Industry and Awards Dinner on Day 1 evening, which is the 3rd of September. Now, this dinner celebrates the achievements of the industry with the pinnacle awards of the Company of the Year and Projects of the Year. This event will be well attended by leading developers, contractors, and architects, so don't miss out on this exciting opportunity to meet and network with the entire value chain of the industry in one night filled with celebration and fun. You can scan the QR code to purchase your tickets to IBEW's Industry and Awards Dinner on screen now. And finally, I'm happy to share that IBEW and BEX Asia will be running a series of experts on tour in the cities of Kuala Lumpur and Jakarta next week. Now, I do know that we have some attendees in this masterclass here today from both cities, so I'm sure some of you will be interested in this. In partnership with the Institution of Engineers Malaysia, we will be hosting a seminar on green data centers in Kuala Lumpur on Tuesday, 1st July. For Jakarta, we are partnering the Green Building Council of Indonesia to run a seminar on green buildings with a focus on energy efficiency design and retrofitting. The QR codes are on screen now for you to scan and register, and the experts on tour sessions are complimentary to attend. So do ignore the 20th June deadline there. Just for you guys, we're extending it. All right, now that I'm through with sharing some of the latest updates about IBEW and BEX Asia, let's get right into today's session, proudly presented by Singapore Polytechnic. We have a 2-hour session, one of the longer masterclasses we have, scheduled for today on various types of building materials that can help contribute towards a low-carbon built environment. We have 4 speakers, so allow me to sequentially introduce our 4 speakers very briefly so that we can get straight onto the content. First is Dr. Lim Chen Bang, who is a manager at the COI BEM in Singapore Poly, specializing in innovation and technology development in the areas of green chemistry, solid waste management, and sustainable built environment materials. He holds a PhD in materials science and engineering from Nanyang Technological University and has developed and commercialized more than 30 technical innovations for local companies, multinational corporations, and government agencies over the years. Our second speaker is Dr. Lee Xiao Dong, who is a manager at the Center for Innovation for the Built Environment, Advanced Materials at Singapore Polytechnic. He specializes in innovation technology development in the areas of solid waste management and sustainable functional materials for the built environment. Our third speaker, Dr. Han, or Dr. Han Dojo, is currently serving as a senior lecturer in Environmental Civil Engineering, Industry and Resources Unit, School of Architecture and the Built Environment at Singapore Polytechnic. He received a PhD in Environmental Chemistry and an MSc in Environmental Civil Engineering, from University of Otago, Dunedin, New Zealand, and University of Liverpool, United Kingdom. His current focus is on the development of FYP internship with industrial research project collaboration, specifically in sustainable water technology and waste recycling technology. He also served as a scientific committee member in Challenges in Environmental Science and Engineering Australia, a member of International Water Association UK, and fellow member of International Society for Development and Sustainability Japan. Last but not least, our fourth speaker, Dr. Tao Neng Fu, holds a Bachelor's Masters of Engineering and a PhD in Earthquake Engineering from Tongji University, China. He also obtained a Master of Computer Science from the National University of Singapore in 2007 and a Specialist Diploma in Building Information Modeling from the Building and Construction Authorities, Singapore in 2019. Now, can I just invite all our four speakers to turn on your camera, microphones, and just say hello to everyone who's joined us here today. I see Dr. Lim there. Dr. Lim, hello. Dr. Tao and Dr. Han, Dr. Lee.
Hello.
All right.
Hello, everyone.
Hello. Now, gentlemen, I trust we're all raring to go. But before I hand over to our first presenter, that is Dr. Lim, ladies and gentlemen, this session will take about 2 hours. Each presenter will take about 25 minutes for their presentations before we take Q&A at the end of the sessions. Do stay to the end because these solutions are not just new innovations, but they've also commercially ready innovations that you could actually apply in your future upcoming projects. To ask questions, please use the Q&A function at the bottom of your screen, at the bottom of your Zoom screen, and we will address these questions at the end of the four presentations. So if we are ready to go, may I invite Dr. Lim to keep his camera on and start sharing his screen while the rest of us chill out for a bit and we'll wait for our turn. So I'll turn off my camera and my microphone at the moment. Dr. Lim, over to you.
Good. Okay. Good afternoon. Warm welcome from Singapore. And I heard from Suhaimi, the audience actually coming even to South Africa. Welcome. Over about hundreds of the participants today. My name is Chen Bang here. I'm from the Center for Innovation for Built Environment Advanced Material at Singapore Polytechnic. Now, today, the theme of the webinar is regarding sustainable construction materials for built environment. So I'm going to bring you through some of the projects that we conducted that related to built environment in terms of sustainable construction materials. But before that, our Center of Innovation, actually, they are formed together by SP, RP, and TP. And then within the SP, actually, we have two centers, AMTC and 5G Center. They are formed together. And then this whole COI actually led by the SP to come out with different kinds of solutions in terms of advanced construction materials, chemicals, to meet the industry design on the constructions. And then this also, we try to accelerate the transformation efforts in building inspection, material characterization, and repair solution as well. And this center is supported by Enterprise Singapore and supported by BCA as well. Now, what we are doing here, some of the examples, the case study, the projects we're going to go through is fall under the BCA Advanced Material Map in terms of sustainability, productivity, and maintainability. So you'll see a few cases, but today we focus more on sustainability, but some of the solutions actually cross over, not just only one pillar. Some of the material, it can be lightweight, but in the meantime, also using waste incorporated, so it can be cross our sustainability and productivity as well. So in SP, we are focused on different areas, and we will cover some of the project today is, for example, the construction chemicals. How can we using more sustainable waterproofing materials, or even using waste, or even low carbon materials to tackle this issue? And my colleagues, Dr. Lee and others, Dr. Han and then Dr. Tao will share more example how can use the waste incorporate materials to target for functional and even of high performance kind of construction materials. Now, how we engage with industry, actually, there are different ways of the mode of engaging. For example, it's very easy to come out some sort of the preliminary proof of concept studies, and then we scope kind of our understanding your problem statement, we can scope the kind of the work, and then to achieve the deliver milestones. We SP also can assist the company to get the funding from government. Therefore, we move on to number 4, and then do a lot of the R&Ds, and then we are focusing more on downstream apply R&D, then before we can also transfer in the end commercialize to industry to use. But not least, they might be involving some sort of quick trial run to test out some of the existing technology and then do a comparison study to conventional solution as well. This is how we engage the industry and hoping more and more companies from locals and then as well as overseas to come over to work with us to try, even if there are problem statements as well. Now, just to sell some of the background about centers. Now, I'll show you some examples in terms of how can we use, for example, first of all, using construction chemical to achieve sustainability. For example, using bituminous coating, which is the room temperature bituminous coating for waterproofing. Purpose statements from the contractor, they have to melt the bitumen at very high temperatures using the welding torch, LPG gas, and then to melt the bitumen before you can lay on the waterproofing at rooftop, the membrane. And this process involves a lot of the very harmful VOC, smoke, smell. And then there might be alternative kind of the products available in overseas, but it's expensive. Therefore, I think SP come out this kind of the followable room temperature fast drying coating solution, like a glue. I can apply at room temperature without use of primer. And then this can compatible with the lowest grade of bitumen, and then to keep this solution affordable. And then this also, in the meantime, fulfilling the local standard to meet the required performance standard as well. So we have done a lot of the serious kind of the performance, the critical kind of the test, and then work with the company to do a trial run as well, and then prove that it's actually strong adhesion than the welding torch, the conventional one, and provide additional waterproofing layers without the need of primer. So this overall process can help the industry to be more sustainable in terms of the worker friendly and animal friendly as well, because we're not going to use high temperature kind of the process. The second examples, the conventional contractor, they have to use a mechanical grinding to roughen the surface before they can lay the epoxy coating on the tile surface. However, this process is very dusty, not very environment friendly as well, noisy as well. In the meantime, has been raising the concerns for the homeowners and then the regulatory as well. So we have come out with solutions to get more sustainable to tackle this kind of whole process. Is just apply a cream over a tile surface for about 1 hour, then you can actually provide a uniform and then a scratch-free kind of surface on the tile surface. And then this is homogeneous and regardless of the worker skill as well compared to conventional process. So as you can see, the performance is actually having a better kind of adhesions, and then the bonding is strong, even no matter kind of the dry or wet condition, and the skill resistance improve. We have already tried with the industry's collaborator and achieved the roughening within 1 hour with an improved kind of the resistance and efficient epoxies. Then we're definitely thinking to have more company to work with to trial further and then commercialize the solutions. Wood material is also one kind of the materials have been used. And then conventionally, the material suppliers, they have to use the so-called CCA, chromated copper arsenic, to really protect the wood from the termites. So I think this is not sustainable. In fact, the CCA is carcinogenic, and then it's already banned in US already. Then how can we help the local industry to come out with a CCA alternative? So in SP, we come out with different kind of formulations, which is applicable to outdoor wood, in this case, Malaysia Cengkar, to protect the termites. And then we incorporate the alternative of the CCA inside the varnish, or even standalone liquid solution to treat the terminal woods. We improve the formulation by changing different effective ingredients, and then this can be against the Singapore environment condition like UV, humidities. And then conventionally, the CCA process, as you can see from the picture right-hand side, they have to impregnate in the very high pressure kind of the process, which might not be suitable at a multi-story building. Therefore, I think this process also can help to redesign the whole process that industry is using is more sustainable as well. So we have conduct a trial run over the 2 months at outdoor, and then it's proven is termite kind of preventions. We are commercialized to the local companies, and then we're looking for more companies to do a trial and adoption as well. Last of the chemicals that we're covering about sustainable is regarding the nanoglass buildings for heat blocking. As you're aware, Singapore is very hot environment, and then this coating actually can apply on the interior glass surface, which can prevent the solar heat from entering the buildings. And based on the result, internal reflection actually can reduce about close to 10 degrees Celsius, and it can be applied to a different kind of the shapes or profile of the glasses. And then it's very thin, it's about 50 micron. And we have been proven the study together with BCS Skylab, and then it can cool down the thermal energy consumptions reductions by overall 9%, and then achieve other function of the 33% of the, for example, like daylight gray reduction as well. So I think this is also one of the technology we're thinking to promote to the local industry to be used in building to, as you can see from the picture, it's very transparent. For the left is the without the coating, and the right-hand side at the BCS Skylab is with the coating. So achieve this kind of the confidential, raise our confidence to this technology to mark up to the market as well. So I cover some projects that in terms of sustainability using chemicals as an angle. Next project, next segment I'll cover using some sort of materials, especially on the waste and then low carbon material that we try to achieve. For example, the first project is using the asphalts, by using the processed plastic waste for better kind of derivatives. So conventionally, some this project we're working is on the news, and then we're working with some more to come out different kind of versions of the plastic waste contain asphalts. And for your information, conventionally, the asphalts might not be durable and easily wear and tear. Therefore, I think it's looking for a new materials that can more durable as well. Through our study, we find that we can achieve using some sort of modified asphalts to achieve a 40% more durables in a 10-30% saving in costs of room maintenance as well. So, but however, authority like the NEA and then the PUB might be concerned whether this kind of the new material is environment friendly, any kind of the leaching that can go into our water catchment as well. So I think we conduct a lot of study and then design this mix to make sure it's really comparable at least to conventional root materials. Even we have so-called trial runs at the west, near the West Coast side, Jalan Buroh side, and under heavy kind of the truck conditions, as well as the rainy season for over 12 months to confirm this is better, more durable, and then meet the regulatory kind of requirements. And then this is ability adopted by some work and being used already. This is one of the pioneer example how we're working with the so-called company, local company to really engineering and R&D of different kind of the sustainable construction materials. Second example is using, as you know, graphite actually is coming from the lithium battery. And then the battery, after they recycle, graphite is becoming the waste already. Instead of really dump and then, burn and then dump into a Samarkand land, we try to reposition, giving a second life to this spent graphite. And then, but through, in the objective for really how can we cut down the reliance of the traditional cement, which Singapore actually have to import, and then contributing the carbon emission as well. So we try to see the cement alternative and then spend graphite through implementing a very good, efficient pre-treatment method to purify these raw materials. Then we optimize and then design this called the blaster mix and then trial on that. As you can see, the achievement is on par with the conventional cement mix, and then in compliance with the US EPA 1311.CAD level. And then we also conducted the external testing at the industry side, which showed that actually have a very low value, associated value, and very smooth finish as well. So I think this is very easy to be conducted compared to conventional cement mix, and then to give us less crack formation as well. Now, that example, similar logic, and we are using instead of the spec graphite, we're using biochar. It's not new. Biochar has been heavily used in the so-called agriculture applications. However, we try to transfer it, actually, in fact, use it inside as a cement substitution in mortar. And then similar concept, I'll try to optimize whole cement matrix. As you can see, the overall physical properties of the biochar are compatible with the control mix. And we think that it can be used with the improvement of the kind of performance as well. Chemical leaching is also fulfilled. And then even some of the results showing that the biochar derivative of the cement actually showing that able to absorb more CO2 compared to control. This potentially not only cut down the carbon emissions for whole materials, also becoming is a carbon sequestration property as well. And then this project also being interviewed and voted by Zhao Bao. Then we have already conducted and completed all this kind of the lab work and then accreditation testing. And then we're currently in the process of commercialization to our biochar mortar information to collaborator. Definitely we want to expand the scope of the work application, not just only mortar, maybe in the concrete as well. And we welcome those IMC or precast or end user as well to think about how to work with us to trial together. Last example, want to showcase is regarding the fiber reinforced concrete is not new. And then Singapore has been using that as well already. However, fiber is also currently, can we use instead of the so-called virgin fibers, can we use and recycle waste fiber as well? So we had done that with the local industry to really clean process and then to reincorporate this kind of the waste fiber into the fiber reinforced concrete in the grade 30 concrete, and then which can be widely applied on wall, walkway, and floor as well. And then we have compared the performance, those kind of the life strength leaching is comparable to the waste tire fiber reinforced concrete as well. And then overall speaking, this kind of the microfiber usually help this surface crack control, and especially for the plastic shrinkage at the early stage. So I think this recycled tire fiber can be potentially to be a new fiber material as a concrete. Now I just finish up all these kind of the introductions of the projects. If I'm really appreciate if you have more time and interested, we can connect and then reach out to us to do more kind of the collaboration of projects and sharing you our website. And then you can scan even the LinkedIn's for latest news and update of our progress as well. In this case, I will wrap up my introductions. Thank you.
Thank you, Dr. Lim. That was interesting, especially the tires one. There, I was reading that Kuwait has one of the largest tire graveyards in the world. So maybe that's really ready feedstock for that. Now, maybe I invite the next one, Dr. Lee, to share with us his presentation. And thank you to Dr. Lim.
Okay, good afternoon, everyone. I'm Xiao Dong, manager of the COI BEAM. It is my pleasure to present our projects to you. And following Dr. Lim's introduction, I'll be sharing 3 additional projects related to the sustainable functional construction materials. So the first, the industry ashes and the waste glass are turned into silica aerogel, which is a lightweight material with thermal and acoustic insulation properties. And second, the glass recovered from the end-of-life photovoltaic modules or the solar panels is converted into foam glass insulation panel. And finally, the waste autoclaved aerated concrete is upcycled into supplementary cementitious material. So let me begin with our first project, which focuses on the exciting transformation, turning the industry waste into high-performance insulation coatings made with aerogel. So as the urbanization and the industrial activity accelerate globally, the volume of the solid waste is rising rapidly. One major response to this has been the growth of the waste-to-energy incineration, a process that not only helps manage waste, but also generates electricity. Reflecting this trend, the global incinerator market grew from around 18 billion US dollars in 2023 and is projected to reach 23 billion US dollars by 2033. But this comes at a cost. The incineration produces a large volume of ash as a byproduct. While some of the ash is relatively safer and easier to recycle or landfill, but yet still a large portion of the ash possesses a greater challenge. It contains higher concentration of heavy metals, the salts, and the other contaminants, requiring special handling and treatment. This presents an urgent need for green, sustainable technologies that can manage these byproducts in a way that both safe and value-adding. And in Singapore, waste management is a national priority. The government aims to reduce the amount of waste sent to Samakau landfill by 30% by 2030 as part of its zero waste master plan. And in 2023, Singapore still generated about 6.86 million tons of solid waste, a slight decline compared to previous years, but still a significant volume. And when we look at the ash and the sludge recycling rates, the numbers are concerning. Only 14% is being recycled. So that presents a clear opportunity. What if we could upcycle these ash into something useful and high value? At the same time, the Green Building Master Plan and the Green Mark Incentive Scheme are pushing for better energy performance in the built environment. And the HDB has announced plans to apply cool coatings to all public housing blocks by 2030. And these are solar reflective coatings aimed at reducing the surface heat gain and cooling loads. Now, but there are some challenges. The light-colored reflective coating can reflect up to 90% of solar radiation, but dark-colored coatings, which are increasingly preferred for design and aesthetics, only reflect around 30 to 40%. And worse still, all coatings degrade over time, accumulate dirt, mold, pollution, or repainting layers will reduce their effectiveness significantly. So we ask ourselves, can we do better? So our project set out with a dual goal: reduce the landfill dependency by upcycling the incineration ash and the similar waste streams. And second, to create a high-performance durable coating that offers both solar reflection and thermal insulation. We have successfully developed silica aerogel-based coating made from the incineration ashes, and the coating doesn't just reflect sunlight, it actively blocks heat conductions. So unlike traditional reflective paints, our aerogel coating actually can maintain its performance even when it's covered by dust, dirt, or painted over. It continues to act as a thermal barrier no matter what layer sits on top. So with support from the Urban Solution and Sustainability Innovation and Enterprise Office, we successfully licensed this technology to Capil and spun off a company called Asius Resources to scale the silica aerogel production. The silica aerogel is a remarkable material known for its ultra-low thermal conductivity, lightweight structure, and excellent fire and sound resistance. It's widely used in high-tech sectors like the oil and gas or aerospace and the military insulation systems. But there is a problem. It's traditionally too expensive for widespread use in the building industry. So we tackle this challenge head-on by using the waste material as raw feedstock, including different kinds of ashes, including the wood chip ash, coal ash, municipal waste ash, and waste glass, and optimizing the manufacturing process to reduce energy consumption and improve yield. So as a result, we reduced the production cost by up to 50% and achieved a thermal conductivity as low as 0.02 watt per meter Kelvin, a level comparable with top-tier insulation materials. And produce aerogel with a density as low as 0.05 kilogram per liter, making it one of the lightest insulation material available. So my colleague Dr. Han actually will introduce more details later. So our aerogel can be processed into multiple formats: the blanket for building envelope insulation, granulates or powders can be used as additives for different coatings. So we have proven scalability by moving from the beaker scale laboratory synthesis to about 10-liter pilot batch process, achieving a 100-fold scale up, and this paves the way for full-scale industry production. We also designed the full industry production line. So how does it perform? So in one simulation test, we coat a hollow concrete box with the aerogel-infused coatings, place them in a 40°C oven, and use the thermocouples to monitor the temperature through the material. With about 20% aerogel content, we observe a temperature drop of 3.3°C, a significant boost in insulation performance. And aerogel's high porosity also makes it a natural sound insulator with sound reduction of 19.6 decibel, ideal for noisy urban environments. And beyond the lab, we have also demonstrated its effectiveness in the real-world setting. At the SP Graduate Guild building, we recorded a surface temperature reduction of up to 15 degrees Celsius after applying our aerogel-based coating. Please note this is refers to the surface of the coating, not the indoor air temperature, but it clears illustrate the material's heat blocking capabilities. And at the JTC Jurong Innovation District Gallery, we achieved a sound reduction up to 12 decibel. So through this project, we have shown how an industry product incineration ash can be turned into a game-changing building material. Our second project focused on the transforming the solar panel waste, specifically the waste glass, into high-performance foam glass insulation panels. As we all know, the solar energy is one of the cleanest and most sustainable energy sources globally. And over the years, the solar panel installation have grown rapidly. And by the end of this year, the global install capacity is expected to reach 2 terawatts. Well, this is great news for clean energy, but it also brings a growing challenge. What do we do with all the end-of-life solar panels? So the solar panels typically last 20 to 25 years. And after that, they need to be retired or replaced. In Singapore, we expect to generate around 5,000 tons of PV waste, mostly due to the early upgrades with only half of their lifetime for better performance and profitability. So to tackle this, we have developed the country's first PV recycling plant. But here's the issue. The glass makes up about 70% of a solar panel's weight, so translating to about 38 to 55 million tons of glass recycled that need to be safely managed. So looking at the element content of the PV glass, which like other glass, primarily consists of silicon and calcium, with additional metals such as the chromium, titanium. So it is important to find a safe recycling solution for it. Our solution is to transform the glass waste into a foam glass panel, a lightweight, porous, and a robust material with excellent thermal insulation properties. We have successfully converted the waste glass into foam glass and focus on optimizing its performance. The insulation quality of the foam glass depends heavily on its composition and the processing conditions. We test different foam agents and carefully tuned the manufacturing parameters. The key evaluation factors are pore structure and size, the pore uniformity, or material density. So too small pores don't insulate well, and too large pores will weaken the structure. And the uniform pores are ideal for strength and performance. So for example, when using the silica carbide as the foam agent, we observe large and uneven outer pores, making the foam glass brittle. And on the other hand, the calcium carbonate can produce uniform pores and stronger samples. And plus, it requires 150 degrees Celsius less energy during the processing, making it a greener choice. We further optimized the percentage of the calcium carbonate. So we found that increasing the content enlarged the pores and reduced the density, but it also weakened the structure. So we identified the 1% calcium carbonate struck the best balance between the insulation performance and the mechanical integrity. And the mixing time also play a crucial role. The longer mixing leads to a better powder dispersion. Our results show that after 6 hours, the density is stabilized and indicating optimal uniformity. The one drawback of the low-density foam glass is reduced compressive strength. So to tackle this, we introduced the fly ash into the formulation, not only to improve the strength, but also as another opportunity to recycle the industrial byproducts and reduce waste. The outcomes were promising. Adding the fly ash improved the compressive strength of the foam glass and slightly increased the density, which can be tuned depending on the performance needs. There's also diverse fly ash from landfills, creating a dual recycling value. While developing these materials, we are also mindful of environmental safety, especially under the conditions like the rains or moisture exposure. We wanted to ensure the heavy metals in the fly ash won't leach into the environment. So we conduct a standardized leaching test following the guidelines from Singapore's National Environmental Agency. Here, what we did, we crushed the foam glass samples, immersed them into the deionized water, and then rotated the mixture for 24 hours before analyzing it using the ICP OES. The results are clear. So only the sample with the 30% fly ash exceeded the allowable limits. For the fly ash contents up to 20%, all the samples passed the leaching safety standards except the lead. So by retreating the ash to remove the lead, it becomes safe to use, and the overall process becomes much simpler. So this project transforms end-of-life solar panel glass and fly ash into safe and high-performance foam glass insulation panels, offering a scalable and sustainable solution that supports circular economy goals and enhance the building energy efficiency. Now let's move on to our third project, which explores how we can upcycle the autoclaved aerated concrete waste into useful construction materials, specifically as a supplementary cementitious material and a partial replacement or full replacement for the natural sand in the mortar or concrete mix. So AAC is widely used building material in Singapore, especially for non-structural components like internal partition walls. It's favored for its lightweight, fire resistance, and excellent thermal insulation. These properties make it ideal for improving energy efficiency in building. However, during the manufacturing process, a significant amount of waste is generated, roughly about 3% of total output. This includes defective blocks, broken pieces from cutting and shaping, and materials that stick to the molds during autoclaving. This waste is commonly referred to as white waste or hard waste. So one company alone generates and disposes of about 250 tons of AAC waste every month. This not only burdens the environment, but also adds considerable cost in manpower, handling, and the disposal fees. The objective is to find effective ways to upcycle the AAC waste and minimize the amount sent for disposal. So our project aims to repurpose this AAC waste by crushing it into a fine powder and using it to partially replace the natural sand in cement mortar and concrete. Given its porous structure, AAC waste also contributes to improve the thermal insulation in the final product. We started by conducting a series of workability tests, including the perpendicular diameter measurement, the slump testing. These tests help assess how easy the modified mix is to work with on site, whether it can be mixed, poured, and finished without major adjustments. The results show that the substitution had only a minimum impact on the workability, making it a practical solution for real-world applications. We then evaluate the mechanical and the physical performance of the modified cement mortar. So we found the density decreased by about 6% at 7 days and 4% at 28 days, respectively, due to the inclusion of the lightweight AAC powder. And despite that, the compressive strength remained high, exceeding 40 megapar, which is comparable to the control mix made with the natural sand. We also analyzed the material's water absorption and void ratio, given the use of the porous material. The water absorption was calculated as the difference between the surface saturated dry density and the natural density, divided by the natural density. And similarly, the void ratio was determined by the difference between the surface saturated dry density and the oven dry density, divided by the oven dry density. So the thermal conductivity was measured using a heat flow meter, which recorded the heat transfer from the hot end to the cold end. Both the water absorption and the void ratio increased slightly, which is expected due to the porous nature of the AAC. But more importantly, the thermal conductivity of the mortar decreased by approximately 10%, indicating improved thermal insulation compared to the standard mix. So to better understand the limits and the flexibility of AAC usage, we also experimented with higher dosage levels with higher AAC cement ratio. The water dosage was also optimized to compensate for the porous nature of the AAC, ensuring the proper hydration and mix consistency. So the compressive strength and the density both decreased with the higher AAC content, and the workability also dropped, as shown by the lower flow meter and the slump values. This creates a flexibility window for the users. If your priority is mechanical strength, you can use a lower dosage of AAC. If you want to maximize the thermal insulation, you can go with a higher dosage, especially in applications like non-load bearing panels or energy-saving building components. So in summary, these projects demonstrate how a common construction waste, the AAC of glass and reject materials, can be effectively upcycled into high-performance building components. And together with our first two projects on aerogel and foam glass, this initiative reinforces our vision to transform construction and industrial waste into valuable, sustainable materials for the built environment. Thank you for your attention.
Thank you very much, Dr. Lee. That was a very interesting one. The use of a lot of construction waste for and upcycling them. Next, I'd like to invite Dr. Han to share his slides. And thank you, Dr. Lee.
Hello, everyone. All right, good afternoon, everyone. Thank you very much for attending this presentation. For the first two speakers, Dr. Lim and Dr. Lee, the focus is more on the detailed research. Perhaps I can brief a bit on my presentation. So I'm from the School of Architecture and the Built Environment. So the purpose of my presentation in here, actually, we try to engage industry by providing young talent. So to do R&D through industrial project and internship. So we focus on the development of silica aerogel and looking at the opportunity on how we try to upscale based on the current research that we are developing in SP. So we're going to start with introducing an overview about Singapore Polytechnic in general and what is the education system, and especially focusing on the engineering concept when we teach our young student here, so that they are able to tackle the challenges and able to support industry. And as mentioned before, we are focusing on solid waste management, especially how the silica aerogel can be transformed into a new unique material. But at the same time, we try to look at support from industry, and also we try to look at the support from our current student. So manifesting people, private, public spirit is very important here before we are able to build up capacity to scale up the research. And some case study will be provided here. So we have some collaboration with internal, external parties, and also international at the moment. Talking about SP in general, I believe some of you understand that SP is the first polytechnic in Singapore. We built since 1954. We have many full-time diplomas, maybe more than 40s at the moment, and current student about 15,000 before this, excluding the part-time student that we have in the training program. So the academic strength, the staff capacity 1,600, and academic about 70% of them. We are sure we are able to help our student and also industry. Our campus is considered the greenest campus in Singapore. We are in Dover Road, about 30 hectares in here. And for myself, I come from the School of Architecture and the Built Environment, specifically from the Civil Engineering Department. So we have a graduate output about almost reaching 200,000 graduate with 114 CCA clubs. As mentioned before, this is how we train our student. We follow a CDIO framework, which is the education framework developed by MIT. In 2009, we become the co-regional CDIO center in Asia 2018, we become the co-director for CDIO International Council. And by 2019, we are able to invite 90 faculty members from the 12 universities, including people Southeast Asian and also from Korea as well for enhancing tertiary education program. Civil engineering is considered one of the most established school in training of professional in the built environment. So this already developed since 1950s. So as we can see there, they're still using chalkboard. This in the beginning, and on the bottom you can see all the picture here. Now we have a lot of presentation and design. So this making all the teaching and learning more conducive. Right. So again, we focus on the how we manage solid in Singapore. So we borrow this concept and from NEA, National Environment Agency, and our focus here is practically is on the waste minimization and recycling, or simply the reduce, reuse, and recycle. In land scarce Singapore, waste to energy in here is getting more important because this offering the best technical solution for reducing waste volume to conserve the land space. And if we follow from NEA, we are actually following the Environmental Public Health Act and under General Waste Collection Regulation and General Waste Disposal Facilities Regulation. And last one is under Toxic Industrial Waste Regulation. In Singapore, our situation, I think Dr. Lee mentioned a bit, so I try to open up a bit details in here. In Singapore, we have only one dumping site, and here this one is already developed in 1970s, and Semakau landfill will run out of space by 2035. So we need to be more resilient. So here the focus is more on the climate resilience, resource resilience, and economic resilience. So, we also need to change our mindset, okay, from linear economy, where we only take, make, and dispose, to a circular economy. So this the concept is we try to reuse, recycle, and also if possible, we try to produce a new resource as long as possible. And our focus in here is more on the sustainable production, in addition of sustainable consumption and sustainable waste and resource management. We have 3 targets based on NEA. We try to extend Semakau landfill lifespan beyond 2035. We try to reduce the amount of waste sent to landfill per capita per day by 30% in 2030. Meaning, so at the moment, if you have 360 gram per capita by 2018, so we try to reduce about 35%. So this will go down to 250 gram per capita per day by 2030s. So this we plan to do it by improving the recycling rate, so up to 70%. In details, we can achieve by 81% of non-domestic recycling rate and 30% of domestic recycling rate. Looking a bit more detail, if we focus on 70% on the left picture, if we look in here, I think from commercial, industry, retail, residential, consumer, if we look at the waste generated at the moment is reaching up to 20,000 tons per day. Currently, only about 60% the waste able to be recycled. And with the incineration process, actually able to prolong Semakau a bit, because in here, from it's about 7,000 tons per day, or 38% of the waste generated. By burning it, by incinerate it, so at the end, it's only maybe about 20% now can be dumped in landfill. So we are able to prolong a bit, but this still not enough. If you look in here, on the right picture, we need to have a green technology to process the waste more efficiently, because at the moment, many of the burning process, fly ash at the moment in the building industry, many people can use it, but the bottom ash, actually, they still have room for development. So in here, showing area of Singapore that's almost full. So we urgently need to process it to make a new material. We may have sustainable production or new transform material, and in the form of silica aerogel at the moment. Looking a bit more detail on the waste management in Singapore, from 22 to 2023, I think the overall recycling rate actually decreasing about 5% from 57% down to 52%. Meaning in here, the domestic recycling rate is stable at 12%, with the non-domestic recycling rate decreasing from 72% down to 67%. So we can see from the data given from NEA, there are many room for development. If we look in here, for example, like ash and sludge, currently only 14%. If you look at plastic, only the recycling rate only about 5%. Glasses also 8%, as Dr. Lee mentioned. We try to recycle the glass, improve more recycling rate. As mentioned before, we are transforming our economy from the linear economy to the circular economy. So circular economy now is becoming an economic imperative more than ever. This compounded with many pricing factors. Yeah, so if you look in here, such as a game changing. So in here, we try to reduce the design, but still meeting the functionality. But we try to repurpose, recycle, refurbish, reduce, and reuse more and more. So the world-changing phenomena have changed the industrial landscape. So in this presentation, we try to explore the green journey that the institution of Singapore Polytechnic has taken from concept, design to development. Okay, for the Green Master Plan in here, we focus more on the green technology, particularly in upscaling and recycling IBA, or incinerated bottom ash. This is how we try to engage people, private, publics. So we try to elevate the scale of collaboration, allowing more multiplier effect on the technology solution with the quicker space and broader range of target of audience. How do we do it? Dr. Lim, I think, mentioned a bit on from the industry point of view. From school, we look from the very basic in the bottom. In the first scale, we have seed. In the seed stage in here, so ABE and AMTC, we work together. We have some basic laboratory tests and practical project. So this, we do it internally. So we have a strong collaboration with our Center of Innovation, especially in the AMTC. And on the growing stage, so here we have industrial collaboration, more partnership, and we have maybe longer internship internally and externally. Here we also have industrial sponsorship to create more solution-minded and FYP. And the last stage, if you look in here, we plan to have more IP filing, more commercialization, stronger collaboration with SME and industrial player, and also international partner. We expect to have more external and internal funding, and more FYP and internship link project. This is the model that we mentioned. Looking at the aerogel project, if you look in here, the objective is how we improve the low recycling rate of ash, but also find a useful alternative for aerogel materials such as thermal insulating material, acoustic barriers, absorbent, catalytic support, and supercapacitor. With the aim is to prolong the lifespan of Smakol landfill. So if you look in here, assuming we have a large company which have many different activities in the daily operation, at the current practice, they have to incinerate, they need to burn solid waste and ship it to Smakol dumping field. So here, SP becoming a provider of technology, and as a consultant, we also able to provide the trainees, manpower for collaboration. So as SME, our role here is we receive the material as an input of the material from company Y, and we do recycling process, upgrade, and transform into the commercial product of aerogel. What is aerogel considered unique in this building material? In here, as mentioned by Dr. Lee before, so this one is considered the world lightest solid materials, composing about 90% of air by its volume and 10% consisting silica nanoparticle in the form of amorphous cross-linked three-dimensional silica network. Because of the high porosity, silica aerogel in here has a unique characteristic. We have high specific surface area, up to 1,200 square meter per gram. We have low refractive index, 1 to 1.08, and low density. With this one can go up maximum only 100 kilogram per cubic. So more likely this one floating in the water. So depending, and also this depending on the porosity of the aerogel. We have ultra low dielectric constant 1 to 2 and low thermal conductivity up to from maybe up to 0.02 watts per million per millikelvin. This is a simple understanding to transform aerogel from solid waste. So we have a raw material of silica aerogel. We have physical and chemical process developed in AMTC lab with the support from our young talent in here. So we did many research, many collaboration, and many internship internally before we are able to make 3 current product at the moment. So currently we have silica powder, aerogel powder, granulate, and another one is the aerogel blanket on the right picture. Some case studies as mentioned. So internally, we are able to install it as a thermal insulator. This one is already installed in our alumni campus in the SPGG. So as mentioned by Dr. Lee before, so this may be a bit more duplication. So at about 11 o'clock, you can see here indoor and outdoor, we have reduction of temperature up to 15 degrees Celsius. Another application with support from our young talent in here, just in JTC, we can see there's a noise mitigation in Tengah Air Base. The test setup, so we have a noise meter and we have a silica aerogel panel, the blanket. As you can see, there's a room that provided, so we installed 2 meter reading. As the result, as you can see here, this very interesting. If you look in here, human activities, if you look on the left, okay, down left picture, you can see it's very, very fluctuative. Almost every minute, actually, we make a very big noise, so we can capture it in here. But if we compare with aircraft noise, you can see in the daily hourly time actually is very, very quiet. And suddenly when we have an aircraft passing by, you can see suddenly we have a big jump. And then slow again, no challenge. And then suddenly another big jump. Okay, maybe this one is a bit far away from the meter reading. Okay, and based on the data comparison, currently our silica material able to reduce about 14% This is based on the lab testing. And on site, we are able to reduce down to about 12 decibels. As mentioned, we also show some in international. So recently, we are able to present it Turkey at the moment under International Civil Engineering and Architecture Conference. In fact, our material is not only from aerogel. On the aerogel residue and aerogel aggregate, this actually has a low density. So meaning in here actually half cooked material. Yeah, this one able to be utilized. No need to process until we make the aerogel. So in here, giving us an opportunity, this or we have a low processing cost, but able to be use it as a concrete mix. Okay, so currently we are still proposing as a noise barrier and thermal insulator. So practically the application for non-structural concretes. Another case that we have in here, we also have a development currently still ongoing. So we test in 3 different room temperature, 25, 35, 45 degrees Celsius. Yeah, so we have concrete skid in here. We test at different 5, 10%, 15 to 20%. So in here we have on the left side we have a hot blowing air. Another on the right side we have a sun penetration. So the room is too hot, even using aircon is still not functioning at all. So we try to install the aerogel blanket to see how the aerogel able to reduce the room temperature. As summary, aerogel is a potentially available material in our lab, and this one we plan to use it for built environment industry. Recently, we have interview. Okay, we have interview from Straight Time, and perhaps we can watch a little bit or in the short video clip how silica aerogel becoming a treasure.
So 54.
Yep. All right. So yeah, as we can see, there's just a summary showing that aerogel material can be used for different application. We can use for noise barrier, for thermal insulator, also water treatment, okay, as a filter, right? So if you are interested in it, okay, you can contact me or Dr. Lee, our partner. Yeah, as you can see, this is actually is a collaborative effort from different staff, researcher, lecturer, and also our internship and FYP student. Thank you very much.
And thank you very much, Dr. Han. That was very interesting. The use of aerogel to block out the sound of the alarm clock. If I were to do that, I'll never wake up in time for work. All right. And last but not least, I invite Dr. Tao to share his slides then.
Many thanks to Suhami for your kind introduction. Good afternoon, everyone. My name is Tao Nung Fu. I'm from School Architecture and Build of the Environment, Singapore Polytechnic. In my presentation today, I will be sharing our innovative approach to utilizing wood chips and sawdust for sustainable construction applications. This work is actually the outcome of a collaborative consultancy project between Singapore Poly and Singuantech Private Limited, supported by the SSG Mentorship Support Grant. This slide shows what I will be covering in my presentation today. I will cover the background of the project, the waste management challenge, our objectives, the solution proposed, research findings, environmental benefits, and our future work. This project actually a partnership between Singapore Poly and Singuantech Private Limited focuses on sustainability and innovation. Singapore Polytechnic brings expertise in applied research, while Singuantech, a renovation contractor, seeks solutions to address wood waste from construction activities. Singuantech and its laboring company generate about 500 kilograms of wood waste weekly, mainly wood chips and sawdust, which are disposed of at a cost of $80 per cubic meter. This presents both an environmental and economic burden. So, to address the challenge faced by Singuantech, a collaborative consultancy project supported by MSG funding was proposed. The objective of the project is to develop sustainable solutions for wood waste and to convert the wood waste into wood cement composites and particle boards. This is uh, uh, to promote circular economy practice in construction. We propose recycling wood waste into durable materials like wood-based cement composites, particle boards, partition walls, and decorative panels. Using eco-friendly binders and low energy method, these products target both indoor and outdoor applications. We sourced and pre-processed materials, performed mixed design trials, and conducted mechanical and thermal performance tests to develop best formulation. Our testing included sieve analysis, mixing trials, casting specimens, and evaluating properties like strength, density, water absorption, void ratio, and thermal conductivity. As particle size affects strength, workability, water absorption, we analyze sawdust using different sieves. They are the sieve size used from 4 mm to 150 mm. Fine particles increase water demand. Core particles, of course, reduce the consistency. Here, the graph shows the particle distribution of AR, which stands for as received sawdust, and OG, which stands for optimized gradation. From the graph, we can see that OG has more fines and smoother distribution curve than AR. Trial mixing has been conducted after the sieve analysis. The mixture contains type 1 OPC, silica sand, or sawdust, and water. The qualitative description of the fresh status as shown in this table of each trial mixture was used for a guidance for adjustment of the mixture design in order to achieve best quality of material. Here, photo here shows that AR cement mortar, which is viscous but flowable with a rough, uneven texture, contains visible sawdust, chunks, and fibers. Gray in color with darker spots where sawdust is concentrated. The photo below is an OG cement mortar mixture, which is smoother and more consistent with fine sieved sawdust and no large fibers. Color is lighter and more uniform due to even sawdust distribution. Workability of the developed mixture was evaluated by flow table test. test. The slant and the perpendicular diameter were measured to compare the workability of the mixture. The result demonstrate the result shown here in the bar chart demonstrate that comparing with the standard control, the workability is poorer when replace sand with sawdust. With OG, the workability is further slightly decreased. 50 by 50 by 50 mm cubes using this mode, right, were cast for the evaluation of strength, density, water absorption, and void ratio. 150 by 150 slabs were cast for evaluation of the thermal conductivity and demonstration of facade design. So from the photo here, you can see that um, the slabs have good surface quality and demonstrate the design details. All right, three cubes. Uh, the cube size, of course, 50 by 50 by 50 mm, were cast for each mixture to evaluate the strength, density, water absorption, and void ratio. Both 7-day and 28-day compressive strengths and natural densities were measured for the control mortar and the mortars containing sawdust, namely AR and AOG. The bar charts here on this slide present the test result for comprehensive strength and natural density of mortar mixture at 7-day and 28-day curing period. Okay, from the previous slide, the bar charts showing on the previous slide, we can have a few key points. At a 7-day, the average density decreased by 9% in AR and 12% in OG, while the compressive strength decreased by 43% in AR and 47% in OG. At a 28-day, the average density decreased by 8% in AR and 11% in OG, while the compressive strength decreases by 9% in AR and 10% in OG. The difference in 7-day and 28-day compressive strengths suggests that the delayed cement hydration and late strength development with sawdust. Overall, we observe density reduction of 8 to 12% and initial strength reduction of up to 47%, but significantly strength gains, were loaded at 28-day. Water absorption of the developed mortar mixture were measured by comparing the natural density and the surface saturated dry density. Water absorption increased with time in sawdust-based mixes, especially in OG. This indicates delayed water uptake and hydration behavior. In opposite the controlled mixture, the water absorption initially lower but higher on 28th day when the sand is replaced by sawdust, right? Especially OG has a higher water absorption value than AR. Void ratio of the developed mortar mixture were also measured by comparing the surface saturated dry density and oven dry density. Mixtures with sawdust showed higher void ratios, particularly OG, which impacts strength and durability but may help insulation. Void ratios are generally higher in the mixture with sawdust, especially in the mixture OG. So these two photos shows the void ratio of mortar mixture at the 7 days and 28 days respectively. The thermal conductivity of the developed mortar mixture was measured at 25 degree, 30 degree, and 35 degree at the Celsius using a heat flow meter on 7th day and 28th day from the casting respectively. The thermal conductivity was significantly reduced in OG mixture, about 27% lower, indicating stronger potential thermal insulation applications. Thermal conductivity slightly increased in AR, but decreased drastically, about 27% in OG, both on 7 days and 28 days. So these two bar chart shows the average thermal conductivity of mortar mixture, all right, at the 7-day and 28 days respectively. As the various wood chips and sawdust size may lead to homogeneity issue of the mixture and in turn affect the strength of the particle boards. Trial mixing has also been conducted after sieving the as received wood waste. The mixture contained wood chips and sawdust, resin and additives. After filling the mixture into a 100 by 100 by 10 mm mold, it was placed in a hot press machine to compact the mixture into a particle board. So here, we fabricated the particle board using a hot press and various sawdust recipes, achieving uniform thickness and homogeneity uh, particle boards. So you can see from the photo here, these are the samples of particle boards with different recipe. The thickness is from 6 to 8 millimeters. Okay, the key findings from this project for cement mortars: sawdust reduced density and workability, delayed hydration, but strength improves by 28 days. OG is better for insulation, but more porous. Replacing sand with sawdust in cement mortar is feasible, but adjusting the sawdust dosage is a key. For particle boards, recipe for fabrication of particle boards has been established after sieving the as received wood waste. Board thickness and uniformity can be achieved. Homogeneity is critical to mechanical integrity. Obviously, this project has a environmental impact and industrial value, right? Um, this project actually diverse 500 kilogram of wood waste from landfill. It saves the cost and carbon footprint from waste transport and disposal, supports green construction through circular material reuse, promotes low carbon alternatives to conventional sand-based materials, a potential for commercialization of sustainable panels and boards, applicable in partitions, facade panels, interior furniture. It provides lightweight and thermal efficient solutions for BCA Green Mark standards. It promotes local sourcing of secondary materials, reducing reliance on imports. Let me wrap up my presentation by conclusions and future work. For conclusions, this project obviously demonstrates a pathway to sustainable construction. It encourages industry-wide adoption of circular practices. It reinforces commitment to innovation and environment. For future work, we aim to scale up production with local manufacturers, apply for green certification and grants, develop new composites with other type of waste. So with that, I conclude my presentation. Thanks for your patience and your attention.
All right, thank you, Dr. Tao, and really thank you to the patience of the audience. I noticed only about 2% dropped out, even though it's been 1.5 hours. So thank you very much, everyone. May I invite all our panelists to and speakers to turn on the camera and microphones, because it seems like we have quite a fair bit of questions to go through. So thank you, everyone. And hello back to Dr. Lim, Dr. Han, Dr. Lee, and of course to Dr. Tao. So I have a number of questions. For those of you who have questions in the audience, you can use the Q&A function in Zoom to ask your questions, but I'll start grouping some of these questions together because there's some similar topics. First one, I think is a lot on the technicalities of stuff, which is on biochar. So two questions here on biochar. The first is, can you use coconut fiber or shell or fiber? I guess this speaker probably comes, if I believe, yes, it's from Indonesia. So there's a lot of opportunities there from the plantations, as well as what are the leaching characteristics of raw biochar. So perhaps Dr. Lim or Dr. Lee would like to take that.
Okay, I think definitely the coconut shell fiber could be type of a source of the biochar. But when we're doing this project, is currently we are focusing more those waste source available in Singapore. Like for example, rice husks, woods, kind of the things. Therefore, I think definitely because be possible. But I think you need to do a kind of study for that. Hope this answer that questions. For the leaching characteristic of the biochar, or especially the raw biochar, I would say this vary with the sources of the biochar being produced locally. And usually, because you know that in my beginning of this biochar topics, usually biochar used as a fertilizer. So I think the supplier have to be ensured it is safe enough to meet the Singapore standard example 698 before it can be used. And definitely we have to make sure it's safe to be used before we can even use in the construction material as well. Hope this answer for the biochar questions.
Yes, sorry. So of course, if you are from outside of Singapore and you're interested, you can of course get in touch with SP, and I think they will be happy to look at exploring the use of alternative feedstock for biochar for that. On aerogel, now it seems like Dr. Han you had, and Dr. Lee had answered some of the questions, but I think let's also take these questions from the Q&A and so that it can benefit everyone. Two questions. One is concerns on VOC from aerogel when being used indoor, as well as biosafety for workers who are installing and using the materials of silica aerogel for thermal and noise insulation. Perhaps Dr. Han and Dr. Lee, you'd like to repeat your answers here for the benefit of the rest of the audience.
Yeah, perhaps I repeat the answer, and for detail, I think from Dr. Lee can support me because my side is more on helping to rotate the ecosystem. Yeah, so as silica aerogel is composed of amorphous silica, the toxicity actually has been extensively studied in recent years by US EPA and OECD, including OSA. And these studies have concluded that the amorphous silica actually has a minimum concern for human health. So the blanket, if we talk about the blanket, this will be packed and encapsulated for the end of user. And yeah, for installation, it's recommended. I think people to wear PPEs when handling the material because maybe some initial installation, some dust may be still being released. But currently, depending on the type of aerogel, we also studied on mixture or paint mixture, and also another one maybe as a concrete screed. So in this case, I think volatile organic compound, some of the toxicity may be lesser. Okay, thank you.
Right, and Dr. Lee on
Okay.
yep.
Regarding the VOC of the silica aerogel, so the silica aerogel actually is a complete inorganic materials, even incorporate into the blanket. So we don't use any of the glue or any bonding for the aerogel. So there will be no VOC released. Yeah, so complete safe.
Right. I think this question on VOCs and biosafety has been important. Right? I believe recently Australia was going to ban one of the popular form of tabletops, counter tabletops, because when you cut it, it releases a lot of dust and it will be lodged in the lungs of the workers. So this is something definitely we need to look into. Let's move on to the question on let me see here. All right. What is the percentage of municipal fly ash in the aerogel? Perhaps Dr. Lee, you might want to take that.
Okay, for the fly ash, actually, sorry, you mean the municipal ash in the aerogel?
Yes. What is the percentage of municipal fly ash? Do you use maybe 20% of the aerogel is made up of municipal fly ash or lower?
Oh, for the municipal ash, I guess you mean the yield of the aerogel. So we have tried different source, including the wood chip coal and municipal
Mhm.
ash to convert into aerogel. So the yield of the aerogel is depend on the silica content in the ash. For
Mhm.
some ash, like the coal ash, actually have a very high silicon content, can up to 50, 60%. But for the municipal ash, the silicon content is low,
Mm.
around the 10%. So the yield
Mhm.
of the aerogel will be lower compared
Mhm.
to the aerogel fabricated from the other ashes.
Right. So the feedstock depends, will be what dictates the yield and the effectiveness of the aerogel then.
Yeah.
All right. Okay. Now, it looks like we have a question that is directed to Dr. Tao. For the
Yeah.
utilization of wood chips and sawdust, first question is how is this influenced by the tree species? And second, which tree species is your study based on?
Actually, generally, this is a general food waste.
Mhm,
There's no specific trees because we collect the waste from the furniture plants
mhm,
in a building. So, of course, Synquantic, just now I mentioned in my presentation, is our collaborator. So
mhm.
they were actually the company collect for us and deliver to SP. Then we will
Right.
do pre-process. Yeah, there's no specific trees, yeah, selected for our research.
I see.
Yeah.
But do you think that, given that there's a lot of differences between, for example, if you use Chengal wood versus, say,
Mm.
a European hardwood, the amount of resin inside the wood, do you think that will make a difference in your project?
Uh, that's a good question. Yes. In fact, this is our phase one
Mm-hmm.
study. All right. It's just about 6 months.
Mm,
We phase one we work with Simquantic, so we
mm-hmm.
have planning for phase two and phase three. So perhaps
Right,
this could be our focus.
right,
So to focus on different trees species.
right.
Yes. Yeah.
Yes. I guess in Singapore, if you're talking about furniture, Chengal wood is a little bit more premium, but of course, we
Yes.
have many other types of hardwoods in Southeast Asia that's being used for
Yeah.
furniture.
Yeah.
Yeah. Okay. Now I think, I think the aerogel one, there's even more questions coming in. How does our research on aerosol fabrication from ash and plastic derived bitumen compare with global advancements in waste-based building materials? Specifically, where does our work stand in terms of performance, cost effectiveness, scalability, and sustainability relative to international benchmarks? Very big picture question. So, if I were to break it down, based on what you guys have been doing, how does it compare to the international work that's being done on upcycling construction waste? And what's the difference, unique stuff that you have been doing that will set you apart from international work? Perhaps I'll throw this open to any of the four speakers here.
Maybe let me start with it. Okay,
Mhm,
I think Singapore, because we our research first of all, of course, address our Singapore concern for
mhm,
the focus of Singapore construction industry. Yeah, then next, of course, we have international collaboration and cooperation. So
mm,
our primary goal will be, for example, for construction industry is to focus on Singapore construction industry concern. Then
mm,
next, of course, we'll work with the overseas. Yeah.
mm. Right.
So in terms of the standard, okay, for example, aerogel and other recycling materials, we are not, of course, we are not the leader, but we are also at so-called very competitive also level.
Mm,
Yeah.
I see.
Otherwise, the BCA, the the funding will not be given to us. We can just buy in. Yeah.
Right.
So that means uh, perhaps in overseas it is the result can be applied to the overseas in construction industry, but may not be suitable. We have to do customization. We have to
Right.
do some fine tuning. Yeah, to apply to the local construction industry. Yes.
Yes. And I think even though if it's local, given that we are situated in Southeast Asia, and a lot of our
Yes.
climatic conditions and practices
Exactly.
in construction around Southeast Asia is similar, a lot of these solutions can also be implemented in the region, right?
Yes.
Yeah. And do see a lot of people, all even Cambodia, Malaysia, Indonesia, Philippines attendees here.
Yeah.
Anyone else would like to add to that response by Dr. Tao?
Yeah, perhaps I can add a little bit more.
Mm-hmm.
Yeah, thank you, Dr. Tao. I think this giving us a direction because again, if we look at uh, aerogel production, actually demand actually is from national because of
Mm,
land scarcity, and we have only one dumping ground in Semakau.
mm-hmm.
This actually is offering on from challenge becoming an opportunity.
Mm,
So we from Singapore Polytechnic, we provide human resource. At the same time, we look at these challenges becoming an opportunity for us to grow. And as shown before, this aerogel material becoming less climate or sensitive, because I mean this product can be a new product, a unique product that with the same process we are able to duplicate, like what I just shown before. We have a partner in Indonesia, and we have some collaboration. We want to see and how if we test it in Indonesia with our partner using the aerogel developed from our material. But
Right.
we don't know if we look at the bigger picture, perhaps using the same process of cooking, for example, rough idea, the same process of cooking, perhaps we can use the local material to look at I can say, the bigger development. We don't know.
Mm.
So at the moment, we look at the, simple application based on our current capacity. Yeah, thank you.
Okay, so now a lot of the questions that I have not picked up are now going more big picture than it is specifically about the products that was shared here. One of the questions here from an Indonesian attendee here is how can sustainable materials be implemented effectively in developing countries with limited access to green technologies? And it follows up with is there any noticeable advancements in bio-based or recyclable materials currently used in structural applications? I think the big picture one is, perhaps less developed countries may have less access to green technologies, but how can they still implement sustainable materials? Uh, Perhaps if I would like to maybe invite again Dr. Han, to share your thoughts.
Yeah, again, we are transforming from linear economy to circular economy. So I believe we can look at different element of processing and availability of the material.
Mm,
Again, as we demonstrated before, aerogel initially we plan to use it uh, perhaps as a mixture of building material. But along the way, we can expand it. We can explore. The application also can be used to treat oil spillage. So this another exploration. And another round, we look at the unique material can be implemented for noise reduction, or can be a thermal,
insulation.
reduction.
Yeah.
Yeah, so a thermal insulator. Yeah,
Yes.
so I can say the sustainability is also depending on the demand or the process. Yeah, so there are many elements that we can work with.
Mm.
Yeah.
All right. Now, there's quite a fair bit of other questions here. Let me just make sure. All right, here we go. The next one, I think this is always a question that comes up in every masterclass that I attend. Uh, Great products, but what is the cost analysis with the products versus traditional material cost? So I have this from the live audience and people who have also submitted the questions. Uh, during registration. So how does this perform cost-wise? Because I think, we all understand the industry does face cost pressures, right? Of course, recently though, fortunately, things like material prices such as steel rebars has been going down, but there's still cost pressures. How would you compare these new materials to traditional solutions? Perhaps someone here who has worked on a more commercial basis with any of the project partners, if you could share the takeaways of your commercial partners on this idea.
Yeah, can I say something on that?
Yeah, sure, Dr. Tao.
Yeah, uh, 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 I think, of course, just like a clean energy solar panel, in the
Mm,
beginning, of course, the cost is always high. All right, but with the technology advancement, with the wider and wider application, the cost will be, you know, uh, going down and down, less and less, so
mhm,
cheaper and cheaper. So, of course, in the beginning, of course, there will be always the government to innovate, give to encourage the industry people to use it, to make use of the, the technology and apply widely to many projects. Yeah. So just like, for example, the building information modeling software, yeah, previously, traditionally, we use 2D. right?
Mm.
Nowadays we use 3D modeling, intelligent building, all this. But in the beginning, it's very hard. But government take the lead, take the lead. Government sectors take the lead. Then educate the small and medium enterprises, and of course, encourage them to do it. Then eventually, more company make use of the new technology, new materials, right? Of course, on the other hand, our research and education academic institutions will put on more focus on the research to improve the materials. So the price will be less, and the advantages will be more. So I think that is the future. It will take time. Of course, you cannot see immediately. It will take time. Yeah.
Yeah. I
Yeah.
think this is also one of the topics that will be discussed at the upcoming International Built Environment Week, right? Where we have a panel that introduces several new to the market sustainable construction materials, everything from low carbon concrete to I'm working on pulling a new wood technology company to come to Singapore. So this will be some of the materials that you can explore. But I think there's also a panel discussion about what are the challenges that impedes the adoption of sustainable building materials, because we all understand that in the end cost matters, and it is also a matter just like manufacturing anything, right? There's economies of scale. The more users there are, the more production becomes cheaper per unit cost. So I think as Dr. Tao has said, you have sometimes the government need to take the lead. I did see that we have some government officials attending this particular webinar from Malaysia, Vietnam, as well as also Singapore. So perhaps that's something that you might want to take into consideration in future project plans for that. Now, moving on to the questions here, we have time for probably 2 or 3 more questions. Now, since it's 3:45, there's a question here with to all the researchers. The use of advanced construction materials is to be guided by BCA under their Advanced Construction and Innovation Planning to follow up with their reference guide for concrete-related innovations. So the attendee here is asking, what have you done? Did you do that? And how closely aligned are you with in terms of these guides?
Maybe I'll take these questions. Actually, we, the researcher in the SP, we are following strictly those kind of the reference guide or even some sort of standards to be doing the concrete related innovation. In fact,
Mhm.
we are working, actually, to be frank, we are working closely with BCA, the
Mhm.
so-called our Center of Innovation, working closely with BCA to develop kind of the reference guide for the concrete related innovations handbook also already. I think it
Mhm.
should be launched in the market soon by BCA. I think
Mhm.
therefore definitely we're following quite strictly to what we
Mhm.
have been doing, no matter kind of the testing, performance
Mhm.
analysis, all following this kind of reference kind of informations.
All right. So obviously, particularly in Singapore, it will have to be guided by the Singapore standards, right, and guidelines. So of course, anything that you guys develop and you're looking to work with our regional markets, you probably will have to do additional testing to ensure that they comply with local standards. Now, speaking about concrete, there is a question here. Any thoughts, insights on concrete, on cement-free construction materials to better decarbonize concrete or other construction materials? The big question here is, can we stop building with concrete in the first place, right? With cement. I think there are examples. We have mass engineered timber. We have various other building materials. I think more suitable for the European climate. Some of them are using hemp as new materials to supplement the cement. But what are your thoughts here, gentlemen, as researchers sitting in the tropical island of Singapore?
Maybe I start to give 2 points.
Mm-hmm.
Actually, there are potential kind of the materials available used already. Example, geopolymers has
Mm-hmm.
been identified one of the potential, even up to 90% of reductions
Mm.
compared to Portland cement already. And it has a very good chemical and fire resistant to be used in the precast and infrastructure, example in Australia and Netherlands. And then this is the potential, but I think also the key thing is the other materials like the carbon cure, the mineralization of these materials. Can we inject the capture CO2 inside the concrete during mixing? I think one of the leading company local like PenU, they've been working on that already. So I think there are various kind of things, but I think Singapore being a so-called imported countries, we always talk about this kind of the cost and to really how can this material close the loop, and then but I think there's a journey for us to instead of really completely using this kind of the new material have been used in overseas, can we use some sort of local generated waste to derive it and then more like customized to be local use as well. That I mean, in the meantime, not only solve the reliance of the polycement import, as well we can try to improve the recycling rate of our waste
Mm.
as well. These are two
Yeah.
points I want to highlight.
Any others would like to chime in with your thoughts on the use of, is there anything that you're aware of that could replace cement as a form of construction material?
Can I say something?
Yeah, sure, of course, Dr.
Yeah,
Tao.
I think in Singapore it is. I think you totally avoid concrete, which is impossible because Singapore is short of land, right? We go high rise, we go up vertical. Yeah, yeah. So, but the key for Singapore is to number one, just Dr. Lim, he has mentioned that we use recycling, yeah, increase the recycling rate. Another one, we have to look into the building life cycle, meaning from very beginning, from the concept design to the demolishing. When we demolish the
Yes.
building, we have to look at the, we cannot just dump into somewhere. We have to recycle the cost, for example, the aggregate rebars now can be recycled, cost aggregate can be recycled. Then the others, can we recycle it? So now the research is still going on. So I hope one day when we demolish a building, then everything can be recycled, reused, 3R, reused. Yeah.
Yeah.
So it depends which country. If let's say Malaysia, they have a big land, they can go for timber, right? Go for steel. But Singapore, we have go high rise.
Mm.
So the concrete is, of course, the very good material. Yeah, in terms of durability, fire resistance. Yeah, for the strength. Yes. Yeah. So that is
Yeah,
something I want to add on. Yes.
that's an excellent point, Dr.
Mm,
Tao, because
mm,
last year's International Built Environment Week, when I was speaking to one of the speakers, and he said before we even start building, we need to ask ourselves, do we actually need to build? Can we not reuse what we have today? So, and when we design for the future, can we make sure that our buildings are recyclable as much as possible, right? Right now, we just recycle the wirings, the copper, some of the steel, but what do we do with the other stuff? Even if it's MET, do we design a mass engineered timber building today, but when the building is no longer required, what can we do that? So I think that's something that's really interesting. The thinking of everything from a life cycle perspective, from the start to end, and how you can reuse it. And we will be sharing. We will have a panel discussion in IBEW this year on reduce. No, sorry, retrofit, reuse, or rebuild. Strategies for asset managers to enhance their assets, right? Because you can either retrofit your building to make it meet modern standards. You can reuse the buildings. A school can be made into a shopping mall, like New Baru in Singapore. Or do you really need to tear down and rebuild? Can you just do a partial building and a partial expansion of the building? So these are some of the conversations that we will take at IBEW this year, and I hope that our attendees here today, be a sustainability professional, a property developer, or an engineering consultant, this will be something that I think will be interesting to you. I think we have time for one last question here before we release. And let me just, oh, okay. So this question actually is about requesting partnerships and meeting up with you, gentlemen. So there has been two questions here about how can they have meetings with you, as well as how do they get involved with Singapore Polytechnic on doing a project. So perhaps one of you would like to share how they can get in touch with you, as well as get involved with the research team under the Advanced Materials Center.
I think we have it would be good for your side to help us to scan the QR code to our LinkedIn or even our website to get in touch with us. Then we can understand your problem statement of the project work, then scope the work, and then in the meantime, I think one of the things what we can do to lower the barrier of this kind of the R&D projects for the adopter to be used, like for example, getting the
Mm-hmm.
funding from the government. There are a lot of funding. The government is very kind to push for the new sustainable construction materials. This is why HL like BCOI, Center
Mm-hmm.
Innovation on SP, can help you to achieve this. And really appreciate if the company who is eager and then keen to really develop with us together in this journey, feel free to really connect with us. Then we can discuss the project scope together, definitely.
All right, that sounds good because I see a lot of the projects that you've been presenting, the problem statement came from the industry. So this is really an example of academia working with the industry to make sure that the solutions are not just some airy-fairy idea, but has a real-world application. Okay. Now, gentlemen, I've come to the end of the masterclass here today. Thank you very much for your time. Just like to invite any of our four speakers or all four of you to have any parting remarks for our attendees here. Any last words from any of you?
Yeah, perhaps on myself.
Yes,
All
Dr.
right.
Han.
Okay. So any problem, please come to us. We may have a solution that we can collaboratively work together with you because yes, we have resource, we have young talent, we have respective scientists, and yeah, perhaps we can find a win-win solution. Every stage of activities, we have funding, and of course, we also need to have support from industry that uh, yeah, we may see one solution that maybe can improve or can optimize your process or maybe your products. Yeah, I think for us will welcome you. Thank you.
Yeah. Dr. Han, can I also just check you welcome anybody, not even just if they're from Singapore, right? Because I know you have a project with University Pelita Harapan in Indonesia also.
Yes, definitely. We also collaborate with Vietnam. And yeah, along the way, we may have another partner from Indonesia. And yeah, definitely internationally available. Thank you.
Yes. So all our attendees who are coming from all over Southeast Asia, South Africa, Saudi Arabia, I also see one. If you're interested, do get in touch. All right. Now, ladies and gentlemen, thank you very much for sticking with us for close to 2 hours here. This is one of the longest masterclasses that I have hosted, but I found it very interesting and I hope you did too. Do not forget that IBEW International Built Environment Week will be happening from the 3rd to 5th of September. Tickets are now available. Take a look at our website, ibew.sg, to find out the full content. We have 2 full days of IBEW content focusing on construction efficiency, digitalization, sustainability, and government regulatory frameworks in Singapore, with a 3rd day with some complementary programs by BCA as well as our industry partners such as Singapore Green Building Council and Institution of Engineers Singapore. Once again, thank you very much. The slides will be made available for download. We will also be sending an email to everyone who has registered for this session with a link to the email, to the downloads. And for those of you who are interested in getting in touch with the researchers from Singapore Polytechnic, BEX Asia will be more than happy to facilitate such conversations. So do get in touch with us. Till then, till I see you next week. Till I see you in 2 weeks' time for our next masterclass. Thank you and have a good day. Take care.
Thank you.
Bye
All
bye.
right. Thank you,
Thank you.
gentlemen.
Okay.
Bye.
Thank you,
Bye.
everyone.
Thank
Bye
Thank
you
you.
bye.
very much. Bye
Bye.
bye.
Thanks.